Hey everyone, Jason here. Welcome to video 2 of my Smart Home Brewing series. So in this video I want to get more into the details of what's going to make this project really cool. So in this video I'm going to talk about PCBs and how I've been able to use AI to make a really powerful and robust PCB for this project. For those of you that may not be familiar with PCBs, these are the things that are inside your computers and your phones, and they're really doing all the controlling and collecting of information. They're really the brains that kind of make everything run. It's what we put the software on, and the software is really what allows us to capture these signals that we're sending and receiving and turn them into meaningful data. So we'll be able to see this in action later once I have the system more put together. But for now I want to talk about more of the basics of how I actually went about the design. So that you can benefit from this if this is something that you want to try to take on yourself. So as an example of how this has been able to help me, I've actually got two PCBs. One I designed probably 12 years ago, and this was a PCB I designed and made at home. I used an old inkjet printer that actually sprays ink onto paper, which are very hard to find actually these days. And that's what allowed me to make the electrical traces, and then along with some harsh chemicals was able to kind of dissolve the copper and form the traces to make up the PCB. So here is that PCB that you can see here. This one has the components on it. Everything is exposed. So again, this is not super safe, not super robust. But it is functional. It did actually do the job that it was intended to do. And it saved me a lot of trouble from having to connect everything manually with wires. So that's another great benefit of the PCBs. Now, let me show you one of the PCBs that I've been able to design so far for this project. This is the board here that you can see. Now, it doesn't have any of the components on it yet, but you can just see this is a much more professional board. This is the back. It actually has 2 layers, which is a pretty advanced thing to do, especially for an at-home hobby project. And this board has a lot more safety built into it, and this is something I'm going to cover as we go forward. This board is going to have things like overvoltage, overcurrent, reverse polarity. It's got EMI filtering on it, and some other things that I'll detail a little bit later. So this is much more of a robust, safe board that has a lot of protection built into it. And as you can see, it's just professionally made. I didn't actually make this board, I should say that. Their company made this for me, and I'll talk a little bit about that later. But I did do the design of it in regards to component layout, traces, selecting the components, and AI helped me with all of that. So with that, let's go on to some more of the details. Okay, so the first thing I want to run through is how I was able to go about doing this. So again, using AI, it helped me find a company that actually provides software for free to do this. And then this company goes ahead and will actually manufacture your board. So this is just a screenshot, screen capture of the software that I use, so you can kind of get a sense for what's all involved with it. This is a schematic, an electrical schematic of the board that you just saw. So this board in particular will be handling some of the high voltage 120 volt AC components, so the water filtration system, as well as the electrical heating element within the brew kettle. So this will be controlling those circuits, so turning them on and off. And it also has some components built into it to monitor the voltage and the current usage, the current draw of both of those circuits. So the goal with this project for me is to not only control the components, but also measure the power that they're using. So that way I can kind of have a sense for all the inputs that went into my process. So not just the raw inputs for making beer, but also the electrical usage, the water usage, all of that. So I have a complete snapshot of everything that I can use to optimize the entire system. You lay out the schematic, make sure everything's connected correctly, and then it turns into this part of it where you're actually doing all of the componentry layout. So this is what they use to make the board, and it should look exactly like what I just showed you. But again, this is kind of how you lay everything out. And then the company goes ahead and makes it. Real quick, I'll show you the other board. This board is quite a bit larger. This is what's going to be controlling all of the other components, so more of the low voltage components, 12 volt and 5 volt. I think there's 10 circuits on here total. So there are a number of low voltage sensors I'm going to be including, as well as some valves. So I'll be using 12 volts to operate the valves. I think I've got 3 valves. And then 1 pump as well to circulate the water and the fluid during the brewing process. And then I've got 6 other sensors that I'll be using. Flow sensors to measure flow rates, temperature sensor. I've got a system to monitor the specific gravity of the fluid over time, so I'll be covering that later. And then I've also got 2 output signals here that go to the other board, the high voltage board, that actually control the on-off functions. So this board is kind of the main board. It tells the other board when to turn on the high voltage components. So there's two signals for that as well. So, and again, similar. This is the board. Haven't showed you this one yet, but I will. And again, this is how things are laid out. Okay, so before we move on, I wanted to show you what that other board looks like, and this is it. As you can see, quite a bit larger. Now, why is it so large? Did I have to make it this large? Probably not, but I was worried about things like heat buildup and just making sure I could actually fit all the components on, because I'm going to be doing a lot of this by hand or by using some other components that are actually going to help, which I'll show later in the soldering video where I'm putting the components on. But I figured I'd probably need a little bit more space. Now it does, you might be thinking, how much is this costing? This is more expensive. The bigger the board is, generally, the more expensive, especially once you get over a certain size into something like this. But in total, for these 2 boards, after it was all said and done, delivered to me, the cost ended up being about $20 per board. So not bad at all, to be honest, especially for projects like this, because it's a huge help instead of having to do it by hand. So for me, the price is definitely worth it. Again, I ordered 10 boards, 5 of each, and it was roughly $20 per board, all said and done, delivered to me. So not too bad. Okay, the other thing I wanted to talk about is just real quick, how do you approach a project like this overall? And I think the most important thing is just to start simple, start with the basics, and especially when you're working with AI, I like to just start with a general conversation of like, here's what I'm trying to do. What do you think about that? And then you'll start getting into more of the details of it. If you've got some ideas of how you want to control things or how you want to set things up, you can add that in there. And then once you feel like you've got kind of a good foundation laid, like a nice general, here's what I'm trying to do, then you can get into more of the specifics with the AI and the conversation. I'll show you a little bit more about that here. But what I'm going to show you is more of kind of like the later on details of like how I work through some of the problems. And it didn't start like that. I think that's important to note. It started very simple with like, here's what I'm trying to do. I'm trying to control these components. I want to use these to do that. Here's how I'm thinking about hooking it up. And it walked me through that, and we got everything kind of in place. And then I said, okay, I want to add in protection. I want to do all these other things. And then so kind of step by step, I got more advanced with it until the end product that you see here. So we're kind of diving into the middle of it, but I just wanted to outline kind of that overall structure for you. If you take on something like this or anything else, I kind of wanted to let you know how I had good results with it, so that maybe you can try that too. I would recommend not diving in really detailed, like start simple and then add complexity after you know that you've got the foundation locked in of what you're trying to do. So, okay, so now I want to run through a couple of the AI conversation prompts and responses, just so you can get a feel for what this looks like. So first, I want to start kind of simple and then go more advanced from there. I'm not going to dive into the details of this. These are just kind of snippets of conversation I thought would illustrate the process well. But don't pay too much attention to the details, because It's not really, you can't really get anything from the specifics other than just kind of see how it works. Okay, so first of all, this is what I did a lot of, especially for components I wasn't as familiar with. This first one deals with something called a triac, which is essentially a switch that the high voltage circuits use, special kind of switch that can handle alternating current. But anyway, this was something I had never used before, so I'm just starting off very generally kind of asking, like, what is this? I took a screenshot of the actual schematic, the component, and said, what is this? How does it work? And you can see the AI did a really nice job of saying, here it is, here's what it does, getting into the specifics of it. So it does a really nice job of kind of giving you all the details of it. And then I kind of went on to just ask questions about other parts of the components, and it's very similar in regards to the detailed summary of it. For some reason I had caps lock on, don't know why. So this is how it kind of started. For all the components I wasn't familiar with, and then just asking follow-up too. That's the most important thing. Like with these AI systems, trust but always verify. Always go back through and do a check. And if you're an engineer, you're kind of used to this anyway. We're always doing design reviews. It doesn't matter how good you think you are, how many years of experience you have. Good process always dictates that you go back and do a review of everything. So that's really all this is. And then as you go through, because I should stop. It's important to do that because the AI does make mistakes, especially for more technical analysis like this. Like I caught it several times making mistakes that could have led to, nothing dangerous, but just definitely wouldn't have worked. The board wouldn't have worked. So you always got to go through and verify everything. So let's go on now to a more advanced example. Okay, so now we're getting into more of the weeds here, and this is really where you need to have some of the context and background of what it is that you're trying to do. Like I said, because I've got an engineering background, I know the basics of how this stuff works. So when you get into the specifics here, it's especially with electric circuits and components, you have to get into math. But AI is doing pretty much all the heavy lifting. So when you're speccing out specific components, making sure everything is configured correctly, voltage dividers, it gets very technical. But I just wanted to show this as a kind of way to illustrate how it works. What's awesome about this is that the AI, it's showing you everything. It's doing the calculations. It's showing the assumptions it's making. So basically you can kind of quickly, if you're familiar with the subject, you can quickly scan through it, just make sure everything looks right, that they're using the right equations, that the math looks correct. Because I did catch a couple of things where it had made wrong assumptions, or it had assumed that I was using things that I wasn't, like different kinds of components, different values. So, it speeds up the process greatly, but you still got to check it, is the long story short. So you can kind of go through all of this, and at the end it does a very nice job of going through all of everything, which is awesome, especially from an engineering perspective, because this would take a long time to do all this, just to remember the equations and then do everything. And what's nice about this too is if you do have software, it's tracking that as well, so it's automatically advising you on how you might want to change your software based on the findings. That's always great. We'll get into more of that later when I actually do more of the advanced software design. So this is just a good example of some of the basics of what it's showing. That it's giving you a final summary of everything. This is a great example. I'll do one more and then we'll move on. So this final one is just another example of a little bit more of the in the detail type stuff. In this case, it was actually helping me evaluate the, you can see thermal evaluation. So this was making sure the board essentially didn't overheat, which was something I didn't necessarily even think of, although I did kind of generally ask it. And what's nice about the AI, of course, is that it goes down all these rabbit holes for you without, sometimes you don't even mean to do it. But in this case, it was great because it's already identifying components getting over 300 C. So it's like, that's a huge problem, which then kind of opened my eyes to that. And again, the nice thing is that it's doing the math, it's making the assumptions, and then you kind of, go through it and say, well, what if we change, add heat sinks, add fans, mitigate all the heat. And it's walking you through that. And then as it's doing it, it's it's telling you how you can update your board configuration too. So again, just super helpful on all of that stuff. Okay, so with all that, I'm going to wrap up this video. I hope you stuck with me till the end. I know this one was kind of long, but I wanted to make sure that I covered all of that to a point where you could kind of really get something out of it. Although I know it gets like super detailed. So if you stuck with me this far, thanks for watching. If you have any questions or if you need help on something, feel free to reach out. Be happy to have a conversation with you about it. So as I mentioned before, in the next video, we're going to cover some of the soldering stuff and putting the boards together and getting them ready to actually go out and do their job. So look for that in the future videos, and I'll see you in the next one.